Okay, let's get to the end of this page and we'll take a bit of a break before we finish out. We're asked to find the value of the function when x equals 3 on problem 15. And from last time, you remember, this always just means go to the function wherever there's an x, let's put a 3 in its place. So this one works out pretty simply. We take a 3 in the place of x, we put that 3 there. And I solve out everything inside the absolute value brackets first. 9 minus 2, so that gives me 7. And then this minus 4 is still there. And the absolute value of 7 is still just 7. So 7 minus 4 gives me 3. Or in other words, when x equals 3, the value of the function is also equal to 3. Try out problem 16. See if you can get that one figured out using the same techniques. All right, problem 17. This is called the composition of functions. So what is the value of function f when you plug g of x into it? So instead of putting a number in for x, we're going to put the actual function g of x everywhere there formerly was an x in the function f. So you'll notice I've rewritten function f right here, but in the place of x, where x used to be, I've put in just a big set of parentheses. And in that set of parentheses, I'll put what g of x is equal to. That's 3x. All that's left to do is simplify. So 2 times 3x is 6x, and we still have this plus 2. So f of g of x just equals 6x plus 2. Try out 18. All right, problem 19, super quick problem. What's the vertex of this absolute value function? I know it's an absolute value function because it's got those absolute value brackets in there. Remember, when something's written in vertex form, like this equation is, we can see the vertex here and here. The number inside the brackets will become the opposite in the vertex, and the number outside will remain as is. So the vertex of that absolute value function is 2, negative 4. Remember that an absolute value function is a V shape. So that means the vertex right here would be at the coordinate point 2, negative 4. Okay, for problem 21, to find the domain and range of a function, it's often helpful to graph it. So you can use your calculator, but I just drew a quick sketch of this graph. You can see that the two arms of this absolute value function will extend forever to the left and right. So we can tell that our domain is going to be negative infinity to infinity. All x values are possible inputs to this function. The range, however, you'll never get a y value or an output value less than negative 3. So that's my minimum. And in fact, I've made a mistake here. Let's see, we should change that bracket. Should be a square bracket because the function actually can equal negative 3. But there is no maximum. This thing will grow unbounded forever and ever. It will just get larger and larger as x gets either more positive or as x gets more negative. Go ahead and try problem 22. Put this in your calculator if you're not able to graph it well by hand, just to get a good feel for what that graph looks like. And then give me the domain and the range. We've all seen it a gazillion times, but take a minute to enjoy a YouTube classic while you let your brain cool off for a minute. Maybe catch up on some previous problems. Then we'll jump right back in.
Charlie bit me. Ah! Oh! Ouch! Ouch! Ouch, Charlie! Ow! Charlie! That really hurts! Whoa, Charlie bit me. And that really hurt, Charlie, and it's still hurting.
And we're back. Let's take a look at problem 23. I've already done a little bit of preliminary work here. We've got to turn the parent function x squared into a translated, transformed version as per the shifts that have been given. So, if we're translating up to, we are going to put, get the right pen here, we're going to put 2 right here. And if we're going left 4, this is actually going to become a plus 4 because it's opposite inside the parentheses. And they don't tell us anything about making it wider or narrower or dilating it in any way. So we know it's going to be 1, it's just whether it's positive or negative here. Since it opens down, we're going to put a minus. So let's rewrite that entire function. Negative x plus 4 squared plus 2. Take a second, try out problem 24. Problem 25, I've already kind of started on this one as well. Average rate of change from a table. So I know I'm going from the interval of 2 to 5. So down here I get x1 and x2 right here. 5 minus 2 in the denominator. Then I've got to figure out what the function is when x equals 5. So I go to my table. Here's x equals 5. There's f of 5. So 9 minus, and then f of 2. There's 2, so here's 0. And then 5 minus 2. So this is a 9 divided by 3, which is just 3. Try problem 26. Using that same technique. For problems 27 and 28, we'll want to use our calculators, or we could graph by hand. Either way, I've done a sketch of this graph, x squared minus x minus 2. I can see that the graph has x-intercepts at -1, 0, and 2, 0. So anytime it's above the x-axis, positive. Anytime it's below, it's negative. So for positive, I'm going to have 2 intervals, negative infinity to when x equals -1. And then I have one more positive interval when x equals 2, and then on to infinity. Because no matter how far we go to the right in x, I'll always have positive y values. There's only one negative interval, and that's from when x equals -1 to when x equals 2. Take a look at the function in 28, and you don't necessarily have to create a sketch like I did, but you'll probably want to plot it in your y equals and take a look at the intervals. Alright, for problem 29, a graph is decreasing when it's going down and to the right. That's happening from negative infinity to where x equals 0. The graph is increasing when it's going up and to the right. That's occurring from when x equals 0 on to any value of positive value of x that we could possibly choose. It'll keep getting more and more positive as time goes on, or increasing. Go ahead and try that with problem 30. All right, I've got to move a little more quickly through these last few problems, so if you need to pause a little bit on these last few to give the students time to put these in their calculators and or solve them, please feel free to do so. I've done some preliminary work here on problem 31. These are just some sketches. You'd want to actually put these graphs, these equations, into your y equals and look at the graphs. Now remember, once you solve for y, your equations would look like this. You'd then hit the second trace and pick keys, and then pick the intersect option. And then it would ask you to pick a first curve, a second curve, and then guess. So when you guess, you go as close to the intersection as possible, hit enter, and it will give you the coordinates of those intersections. Once you've gone through the steps to find the two intersections, you'll find that you have one at -1, 1, and a second one at 1.5, 3.5. So we'll use those same steps, solve problem 32. Problem 33, we're asked to write this quadratic function in standard form. So all we need to do here is distribute, or some people say FOIL. So you'll notice I drew my arc marks to indicate the multiplications that I need to do. But I have this negative sign that I've got to keep in account as well. So I just store that negative sign here, and then I do all my multiplications. X times x is x squared. X times 3, that's where the 3x comes from. -2 times x. -2x, and then -2 times 3 gives me a -6. And you see, to get my final answer, I take that negative and distribute it through to every term. I combine these first. 3 minus 2x is 1x, and then I make it negative to give me my final function written in standard form. All right, problem 35. We again need to distribute, and then after we're done distributing, we can multiply by 2 and then add 1. So I'm going to keep the 2 outside. Start distributing. X squared minus 2x minus 2x again, plus 4, and then I have a plus 1 right here. Now I just need to multiply that 2 through to everything, and I'll write my final function over here. 2x squared, and then -2x and -2x make -4x. And when I multiply that by 2, it's a -8x. And then I multiply this 4, it becomes a plus 8. But then I still got this plus 1. And instead of writing that on a new line, I'm just going to combine 8 and 1 together. So my final answer is just a plus 9 right here. And that's the equivalent function written in standard form instead of vertex form. All right, so a couple problems left here. To find the max or min, that's going to be the vertex. So we've got to find the vertex. We can identify whether it's a max or min based on whatever number we see in front of that x squared. Since we don't see anything there, there's a ninja 1 right there. And since it's positive, this must be a smiling parabola, meaning this is a minimum. Okay, so we know it's a minimum. And we find its value by finding our vertex. So I've got a 6 right here. I put that in the place of B. And in the place of A, I put a 1. -6 divided by 2, it's a -3. So that's my x coordinate. To get the value of the minimum, I need to plug -3 back in for x. So -3 squared is 9. 6 times -3 is a -18. So 9 minus 18 is a -9. Plus 1 is a -8. So the value of the minimum is a -8 that occurs when x equals -3. For our last problem here, we're gonna talk about a technique we really haven't used that much, because formally, if I've asked you to write a function like this in vertex form, we've completed the square. But there's actually a way that's a little bit easier, and it comes from just finding the vertex. So just like in the last problem, I use the formula -b over 2a. I solve for that by putting a 4 in for b and a 2 in for a. When I simplify, I get -1. And to get the y-coordinate of the vertex, I plug -1 in everywhere there's an x. When I do that, I find that y equals -1. So there's my vertex. Well, I also know that a is 2, because I can see it right there. The value of A is 2. So to write it in vertex form, I can just say, all right, if I know what A is, I can put it right here. If I know what the x-coordinate of the vertex is, I can say, okay, x minus a negative 1, so x plus 1 squared. And then out here, the y-coordinate of the vertex is minus 1. So I just put A, H, and K in their respective places, and I've got the formula for that quadratic, but this time it's written in vertex form instead of standard form. All right, everybody, remember that you are responsible to complete all the problems on the right side. For next time, we'll grade that when we come to class right at the beginning. The substitute will now give you the exit quiz. Remember that during an exit quiz we do not talk. Once you've completed those exit quizzes, the sub will collect those. Remember to write the score for the cumulative review number 1 in the bottom right-hand corner of your exit quiz so that I have that score to put in the grade book. Otherwise, it'll go in as a 0. So just don't forget to write that score in the bottom right corner. All right. Have a great day, guys, and we'll see you when I get back.